what are routers? What do routers do? Well, if all of our other devices allowed us to move data across our same network, allowed us to move data across our internal network, routers are what allow us to move data across to different networks, allow us to take IP addressed packets and move them to networks that have different IP address network, or use different protocols, or use a different topology. So that's what our routers do. They move the data across different networks. They allow us to also perform things such as segmentation and subnetting. They allow us to take our network, which is in our same local area, and subnet out or segment that network, and still allow us to communicate between those networks in our office by taking those data and moving it to those different networks. This segmentation may be necessary if we're trying to help clean up some of our network traffic, help clean up some of our broadcast domains, which we'll also talk about later. Our routers also help manage traffic flow. They help manage where specific data goes next. They help to speed up connectivity by maintaining routing tables and maintaining where data needs to go next in order to get to its final destination. So that's what our routers do, moving data across the different networks. Now, routers manage tables. Now, what does that mean? Routers aren't waiters. So what do we mean by they manage tables? Well, in order for a router to know where to go to next, it has to have some sort of table that tells it where it sends data to. If we just send a packet to our router that says, I want to go to google.com, well, how does our router know where the heck that is? How does our router know where the heck it needs to go to ask what a google.com is? It needs to know where to go to get, if we don't have local DNS with google.com cached, we need to know, okay, well, where do I go in order to get to this DNS server they're referring, in order to bring them back a response, so that then I can go out again and find out how to get to google.com. How do our internet service providers' routers know how to get to all of these different internet addresses? Well, I can tell you now that the little routers we have inside our house don't have all the network paths to all the different IP addresses in the world. They'd be much bigger than just our little tiny routers. Our routers manage tables which let them know mostly the closest networks that we have, the networks that we may have in our environment, in our enterprise, and also let them know of where to go and where to send data if it's not sure, if it doesn't have a routing table entry for this. So router tables let our router know where to send data to outside of its own little network. So if we do have a network that consists of multiple routers across our domain, if we have a big enterprise network with multiple users on multiple different IP address subnets connected to multiple routers across our enterprise, those routing tables will know the best ways to get to the other networks and the fastest ways to transmit data. That's the other part of routing tables. Routing tables also help us to manage not only where to send data to in order to get there, but also hopefully include the best way to get there. If we're trying to send data, or we're trying to send a file to a file server that's on a different network in our enterprise, it'd be best if our router knows the fastest way to get there, so we don't have to go all around the world in order to get to our server. It's best if our router simply says, oh, okay, I know that if I send this packet this way, it's going to take it twice as long to get there and get a response, and then if I send it around this way. So it's best to know, it's best that our routers keep a managed table of that. Now, our routing tables are either static or dynamic. It's either one or the other, and the reason being, dynamic means they're automatic. They automatically update. They automatically change themselves. And static is manual mode. Static, just like our static IP addresses, mean that we need to go in and we need to manage those tables, and we need to add entries to those tables and manage the different paths. Both have their pros and cons. With static, we would have to be constantly updating and managing those tables, and if something were to go down or something were to break, then and we didn't have some fallback set, we didn't have a secondary path set, then our router wouldn't know how to get somewhere else because it wouldn't be dynamically updating. Whereas dynamic, our router may pick a path which may not be the best path or may not be the way that we want it to go. So there may be some hybrid going on there. There may be, we may have a router set to dynamically create new paths and dynamically update its tables, except for this static path we have set, where if somebody's trying to get to this network, they need to go along this path. So if we're noticing that we have networks set up in our network, we're noticing that we have networks set up in our enterprise where we have routers on them, and whenever I'm trying to send a packet here, whenever I'm trying to send data here, my computer, my router isn't really sending me to the right place, or it's sending me this long roundabout way. Or if for one reason or another it wouldn't be able to dynamically find this path, I need to go in and I need to statically set this path. I need to statically put in the information that my router requires in its routing table in order to get from point A to this network that it knows about. Now, when we're using dynamic routing tables, our routers use different protocols in order to find out the best way to get to where they need to go. Now, these include things such as open shortest path first, border gateway protocols, EIGRP, RIP version 2. It's a lot of different protocols, and it's a lot of different calculations and a lot of different components of a connection that are involved with our router determining the best path to get somewhere. Think about it this way. You may know of a couple different ways to get to work. You may know of some side streets and some back roads, and you may know of the highway. Well, sometimes you may take different ways to get to work depending on the time of day and the day of the week. Why is that? Why don't you just take the highway every single day? That's the most direct way, and it's the largest road. Just like with our routing table, with our routing path, we may have a link connection that it allows for the greatest amount of bandwidth, and it's the most direct path to where we need to go. So why wouldn't we choose that every time? Well, maybe during certain peak hours or certain times of the day, that road has a lot of traffic on it, and it's going to take us a long time to get there and to get a packet back. But if we go down these side streets, if we go down this other route, while in theory it initially may seem less appealing because it takes us a couple more hops to get there and the bandwidth is a little bit less, we may still get there faster and may be able to perform our operations faster because that other path doesn't have as much traffic on it. Conversely, we may have side roads that would get us to work more directly than going down another road which goes a long roundabout way. But those side roads that go to work directly may have a dozen red lights in them, may have a very short and narrow road, may have a very low speed limit. So we have this very direct, very straight to work road. We have a very direct path that our router takes very little hops to get there, maybe 2 or 3 hops to get to where it needs to go. But it's a very narrow bandwidth road. It's a very low speed limit. Whereas we have another way around that may take a couple more hops, but we have a higher bandwidth. We have a higher speed limit to get there. So all of these different calculations, all of these different the different ways that our routers get to different locations are included in these different protocols, which take all of these different considerations into effect. Some of them do, some of them don't, which take different considerations into effect for our routers to determine the best way to get to places and assign values as the best ways to get to places. But we'll talk about each of those individual protocols a little bit later. Now, our routers are what we're going to typically set as our default gateway. Well, why is this? Well, our routers will only address direct packets. If we're trying to get a packet somewhere and we're saying, okay, I want to send a packet to this IP address that's not on my network, and we just send that out to everybody and we say, hey everybody, I'm trying to get to this server. Can you send this packet? Can you forward this packet on to this server? Our router won't address that if it's a broadcast packet and sent to everybody. Our routers don't forward broadcast packets. Our routers will only forward packets that are directly addressed to them. Now, our computer, our default, will only send packets that it doesn't know where else to send them. It sends them to our default gateway. So if we don't know where to send a packet and our computer says, hey, I need to send this packet here, but I don't really know where that is, I'm not going to send out a broadcast to everybody and ask everybody to pass this along. I'm going to send a direct packet to my default gateway, who is then going to pass this along. So that's why we set our router as our default gateway, because A, our routers only address packets that are specifically addressed to them. Our routers will only address and they will only pass on direct packets. And B, our routers will only, our computers will send to their default gateway packets that they don't know where else to send. So that's why, that's our router reason. So this is on the router side. Our routers will only address direct packets. And on our computer side, our computers send packets they don't know where else to send them to, packets that are on different networks, to their default gateway. So that's why we set our router as our default gateway, and that's what our default gateway means. It's where we send packets we don't know where else to send them.